presentation. I'm going to use Coding Mouse Exploration, a grade K module, as the example. First of all, I want you to see that we have two partners, Texas A&M and Purdue University, which are top engineering universities that made sure that we have high curricular quality curriculum and true-to-life engineering practices. Each module follows this design engineering process, starting with defining the problem, planning ways to solve it, making prototypes, testing those prototypes in fair tests. Then they present their findings with a team, and then they redesign. Our modules are divided up into 3 different series. The pre-K modules, the adventure series, help a fictitious character friend solve a problem. These are 4 lessons, no more than 20 minutes for each lesson. For example, these are authentic problem-based learning. In Ron's ramp, students help Ron, the skateboarding armadillo, design a ramp that helps him go far, but not too far, into the street. The second series is our K-12 modules, the Explore series, where the authentic problem is they're helping a friend. These modules are 5 to 8 lessons or days, and they are no more than 30 minutes. Some of them may be 20 minutes or 15. For example, the authentic problem for shrinking shores is that students are designing a model to protect the beach from erosion by using netting or breakwaters, which is clay, or a barrier reef. There are 9 modules plus 2 new ones for a total of 11 modules in this series. And then our third series is our 3 through 5 modules, our challenge series. These modules are up to 60 minutes, and again, there are 5 to 8 lessons. Some of the lessons could be 30 minutes, 20 minutes, but no more than 60 minutes for each lesson. Now they are amping up their ability. They are working as real engineers for a client. For example, in Wildlife Corridor, they are designing a wildlife corridor to help animals cross a new highway safely, and they're working for the DNR. As you can see, every module is based on an authentic-based problem, and it starts with a story. We also, each curricular kit covers one of the 3 domains. We have kits in life science, earth science, and physical science, as you can see here. And they are perfectly aligned to the Iowa standards. We have at least 3 at each grade level, 1 in each of the 3 domains. The exemplar I'm going to use is Coding Mouse Exploration. As you can see, it is interdisciplinary for the engineering, the science, the math, and the ELA. And here it shows the national standards that it aligns to, along with some computer science standards. Every kit, every module also has a kit, and the kits have all the materials needed for 1 classroom teacher up to 30 students. There are 6 activity books because they work in engineering teams, and there are possibly 6 engineering teams. There's 1 teacher's guide, and all the consumable and non-consumable materials needed for all the activities in that unit. There's also a simple to use teacher's guide, and in that teacher's guide there are the materials list, the materials that the teacher has to provide, which are very few, and then there's a materials preparation, as well as a teacher planner that shows the lessons, the time it takes, the objective, the grouping, the materials needed, and the black line masters needed. Each lesson, there are 4 to 8 flexible lessons, and the lessons build on the next lesson, and they follow the engineering design process, as you can see here. We also have editable black line masters that teachers can manipulate and print off. We also have a how to use videos online, which are material setup and facilitating STEM. For each module, there is a unique URL code. And then each module starts, as I said, with a story. So in Coding Mouse, it's the kids want to they want to get a pet mouse, but their mom is not too sure about that. So they are going to engineer and make a model to prove to their mom that they know how to take care of an animal, and they will become engineers. So the first problem, the first lesson, they also start with an activity as well as the story. So they're doing a kinesthetic activity and working on coding. Then there is always an informational text and literacy connection page, which also has the scientific content. So students, so the teachers are teaching science content through informational text. In this case, they're learning about different types of robots and different types of coding. Then there are also always criteria and constraints for the design task. In this case, the lesson 3, they are doing a board game and learning about the basic needs of animals. And then they learn about how to code Jack the coding mouse. And then there is a series of scaffolded lessons. And this is true for all modules. There's always these scaffolded lessons where one lesson builds on the next. So in this case, the first lesson is learning on how to follow a code. The second lesson is learning on how to write the code themselves. And the third lesson is learning how to, when there's a mistake in the code, how to debug it and fix it. Then, of course, they use all that data and information that they've learned to plan their own design. And in this case, they're planning their code and their shelter for their pet mouse. And then they test it using a fair test. And if you go to this URL, it'll show the exact coding mouse exploration, and it'll show the end product and the kids the thrill of victory. In the very last lesson, the teams communicate their results and then they redesign. And there's also the ELA connection always at the end, where they can sometimes do some ELA extension. There is also a glossary in the back of the student activity book, and there is an assessment rubric for a summative assessment rather than a black line, rather than a multiple choice type of exam. Our rubric is much more in line with problem-based learning and what the skills they are learning to do. And there is also a family letter that can go home at the end of the unit, in which the family learns what they did, but then there's something that they can always try at home together to bring that STEM and engineering into the home. As I said, we have 25 curricular units total. You can see the 5 pre-K, the K2 ones. We have a new code, the coding mouse is new, and we have a brand new one called which is called Project Park Design, which is coming out in January. And then we have the 3-5 modules as well. Thank you for your time. I hope this helps to explain how our modules work and the format and organization of them. If you have any questions, here is my email address and my work phone number. Thank you.